So hi, my name is Daniel. As you can see, I'm the Technical Customer Success Manager at WinDriver. You can see my email here if you have any questions after this session. Today, we are going to talk about how to develop a cross-platform drivers with automated generated code using WinDriver. This is an introduction webinar for WinDriver. I will talk about a variety of features which each one of them has an elaborated documentation, webinar, some of them, dedicated webinars, um, and instruction videos. All of them can be found on our website. Let's start. So I'll start by saying that this webinar is the first among 4 webinars we will host in this quarter. In 2 weeks, we will host the DMA webinar, intro to DMA, how to implement DMA using WinDriver. I highly recommend to sign up and attend to this webinar if you're not familiar with the concept of DMA or you want to implement one. This webinar is also available on our YouTube because we've already hosted one before. We have a few additions for this one. So you can find it on our website or sign up and enjoy this webinar. It is free as well. On March 3rd, we will launch WinDriver's new version. It will include 2 samples for Lattice devices. If you're not sure what a sample is, we will discuss that shortly. And a new model for our licenses. And the last one on March 17th is another webinar we've already hosted before with some extras. It is about how to implement an interrupt handler using WinDriver, dash how to utilize the PCI diagnostic utility. You can find all the planned events, blog posts, videos, academy under the support on our website. So I'm not sure how you found out about this. How you found out about this webinar. Look for Jungo WinDriver on Google and enter our website. It has a lot of content. Again, this is the address for each section, each content section. We have a debugging webinar, predefined actions webinar, which I will talk about, test sign mode, and other features WinDriver includes. I invite you to enter the website and explore the really interesting content. So what are we going to get done today? Unlike previous webinars, I will start with a demo. We will start from scratch, a new project on WinDriver, see what capabilities it has, how to generate a project, how to build it on any operating system and architecture. And then we will run our user app, our executable file that will include the functionalities we implemented via no-code solution, WinDriver, of course. Then we will have an overview, dive into the mechanism of how it works, go through the major functionalities, the most common ones at least, talk about the utilities we offer that comes with WinDriver, and then wrap it up with APIs. So let's start with an overview. Here we have WinDriver folder. Let's run it as admin. So this is how it looks like. I'm going to ask to host a new project, and then I will have a list of my connected devices, PCI and USB. The reason all of these are listed is because WinDriver supports every PCIe and USB device. If you can find your device here, make sure it appears on the device manager. You can search by VTPID, product ID, vendor ID, and you can choose. So let's, for example, choose one device. Okay, this is USB. Okay, and we will generate an INF for it. What is INF? If you're not familiar with it, INF is the key to access the hardware on Windows. It's a protection measure, among other things. And you need to have this INF file, which is a text file with specific flags and information regarding the developer of the driver to ensure it is safe and can access the hardware. So you can automatically generate an INF using WinDriver, which saves a lot of time. You can see the vendor ID, device ID, which cannot be changed because it is derived from the configuration space. You can change the manufacturer name, the device name. You can choose the class you want it to be related to, memory, multimedia, display, etc. The device class, let's open the device manager. Okay, and we can see it here. So custom is Jungo connectivity. Every INF I will install under the custom device class will appear as Jungo connectivity. It can be edited inside the INF. But this is when we're talking about classes, this is what we're talking about. If you are familiar with DMA already, so there's an option on Windows to pre-allocate a device to host or host to device DMA buffer. Why would you need that? Because sometimes heavy or large processes takes large section and chunks of the memory, so you can pre-allocate buffers from the boot, and this way to ensure the space, enough memory to have to perform the DMA. This device does not support MSI interrupt type, so this is grayed out. You can automatically install the INF, generate a test sign catalog. What is a test sign catalog? INFs cannot be just installed. They need to be signed. When developing a driver, before distributing it, the INFs are not signed. There is a technical procedure that allows you to install INFs, unsigned INFs on a computer. However, it takes time, it's exhausting. What we developed is a catalog file that is viable for installing in test sign mode. So when you install WinDriver, you have the option to check this box, and the computer then shifts to test sign mode, allowing you to install INFs, unsigned INFs, using the test sign catalog. We have a dedicated webinar specifically for this feature. If you don't understand any of what I'm saying and you want to learn more, you can go and see the webinar or read our documentation. And we have a support for Windows 10 Legacy. Okay. I will not generate an INF for this project because there's already an INF installed. Let's call this one Delta, this project. So it says, you don't have an INF installed. Do you want to install one? I'm choosing no because I already have an INF installed. However, if I do not have an INF installed, I will get an error message saying that the device cannot be opened. Okay. And this is the wizard. Okay. This is how it looks like. Let's just overview what we are seeing on screen. You can create a new project instantly. Open one, a project that you've already saved on PCIe. Save this one as, close it, generate code, which we'll get to shortly. open the debug monitor, which is highly recommended in any case. Utilize the WDReg frontend. What is the WDReg? So as we said, INFs are not just being installed like that. There are some commands that allows you to install an INF. We developed a front-end no-code solution to install driver, uninstall them, start stopping them, etc. So if you haven't installed the INF automatically when you generated it, you can install it using the WDirect frontend without the hassle of the command line. Here we have the licensing information, where you can submit a license request, submit the license, deactivate it, see the licenses APIs, your operating system, your architecture, and contact information. Okay. So what are we seeing here? Here we are seeing the configuration space. The configuration space was implemented and set by the manufacturer. It includes critical data information about the device, which information is being contained on which offset, and how to access it. In some devices, you can read and write. Oh, here we see it, to read and write to this register. And maybe even change a few parameters. In this case, we see that if we will read the data from offset 0, we will get the VID, the vendor ID, which is 8086. If we will read the data from offset 2, we will get this number, XD4C, which is the device ID or product ID. We can see everything here in the configuration space, again, as set by the manufacturer of your device. Here we can see the memory bar of our device. We have a single memory bar. You can see the range of the device, the addresses. And then you can add access registers or import them as a bulk. What is an access register? Access register is, as we saw here, are gateways, are doors to specific functionalities of your device. So, for example, here on offset 2C, there is the subsystem vendor ID, which is this one. Some interrupts raise some offsets raises interrupts, some offsets perform a power event. Each device has its own specifications and offset list, and the developers must be familiar with the offsets of their device, and it's critical because reading or writing to a wrong offset or performing certain operations can cause a crash or even burning the card. So you must be familiar with your device's offsets, and you can add access registers. Okay, so for example, this one, acknowledge interrupt. Okay, bar 0, we can choose if we want the direction to be only reading, only writing, or both. Choosing the relevant offset of the device and choose the size. I'm just giving an example here. Here I've added an acknowledge interrupt register based on the offset of my device specification. Now I can read and write to it. Okay, to this specific offset, choose the data, choose the size, whether read or write, and so on. What we've just did from opening the wizard is basically accessed our device. We can see the configuration space. We can see the memory bar. We can define access registers. We can read and write to it. No code, no building of anything. Download WinDriver, open the wizard, and you have an instant access to your device, which is very easy. Some things I'm doing here can take days to develop, and the ease of use here is very clear. It is something on every step here. The ease of use is following us. Interrupt. You can. We have a built-in interrupt handler. We have functions that listen to interrupt. You can add transfer commands to the interrupt. You can do so via the wizard or via the application or via the functions, which I will get to later. If I click on listen to interrupt, WinDriver will start listening to interrupts from the device. Once an interrupt is raised, it will be acknowledged. Okay? So this functionality is, I want to say, built-in WinDriver, using WinDriver's API, and not just listening to interrupt, but you can add transfer commands. What are transfer commands? Transfer commands are packets of data, information that is being passed to the CPU once the interrupt is raised. So you can add the transfer command. Okay, here for the access register, you can choose the direction, you can choose the data, and once the interrupt is raised, you can this message or this command will be sent in the flow. PDA, I won't get too deep into that because we have a dedicated webinar for it, and I want to overview WinDriver, not this specific feature, but basically PDA allows you to create a flow, a sequence of operations, of actions that that will take place one after another. So let's just give one the name, calc. If I want to calculate something, okay, so I'm in the predefined action window. I can add a transfer command based on the access registers of my device. Again, choose the direction, choose the data, click OK, and add it. Once I'm adding it, it will be placed in the sequence, in the flow. So if, for example, you want to create a flow that performs a certain calculation, then raises an interrupt, then clearing the data from the register. You create access registers, adding them here, one after another, click run flow, and you can see it happening right here. Just remember, if you want to know if an interrupt was received, click on listen to interrupts. So here we have the calc PDA. You can run the flow, and everything that I'm setting up here, the transfer commands, the access registers, the PDA, will be generated on the code afterwards. So this is the wizard. These are the functionalities that it allows you, saving a lot of time and a lot of effort coding just to access the device. Now, let's generate our project. Okay. In this window, we can choose a device-specific customization. What does that mean? Our development team created specific samples for Altera and Xilinx DMA designs, IPs, okay? So for Xilinx, it's the BMD design, the QDMA and XDMA, and the Altera Avalon only memory mapped, okay, IPs. We have the design for Stratix 10 and Cyclone 10, and also QSys. So if you're using Altera or Xilinx, we highly recommend the XDMA design, but again, whichever design you choose from to add to your bit stream on Quartus or Vivado, your IDE or studio of choice. We won't choose any DMA design, and I will talk about DMA more afterwards, specifically also about the XDMA. WinDriver is not only for C developers, it's for also .NET, C Sharp, .NET Core, .NET, Python, Java, and C, which is very common. And we can choose the IDE. We recommend our best practice is to work with the CMake makefile. What is a CMake makefile? CMake makefile is a text file that contains the flags and definitions required for every operating system and architecture. What that means, that if you want to distribute your driver and or build it on different platforms, you can do so only with this file, and you don't need to change anything. You can just get the package, move it to another environment, and use the makefile, the CMake configurations on your IDE, whether it's Linux or Windows, to perform to build your solution. Very, very convenient. I will demonstrate how it is done. We will build our project with the CMake. Another feature we offer is the NSYS installer. If you're not familiar with NSYS, so it is basically an executable file, very convenient for your users. In this way, all they have to do is to click an installation file, executable. It will include the terms and agreements. It will include your driver's version, the manufacturer, and it will make their life easier as well, not only yours. Okay. Before it generates the project, WinDriver asks me if I want to generate a separate library for application logic. What is the separated library for application logic? Our product eventually will be a diagnostic app, okay, an application that will include all of our functionalities we've added on the wizard so far and in the code itself. Sorry. So since it is an executable, it is a whole application, we have the UI. We have a component on our code that includes the interface. If you click here, you will get only the logic, not the interface, and this way you can implement this functionality, the functionality you've added with WinDriver on your interface, if you have one. Kernel plugin. Kernel plugin is for advanced users. We'll talk about it in the presentation. Essentially, kernel plugin is chunks of codes moved to the kernel mode. This way, you don't have the context switch when performing operations. Everything is much faster, especially interrupts. You can implement an interrupt handler in the kernel plugin. We are planning to host a webinar about kernel plugin and how to use it next on the next quarter. So stay tuned. And that's it. Just by clicking OK, I have my project ready. You can see it's called Delta. Let's open it and get back to it shortly. Now I'm getting a warning that says, make sure that WinDriver is closed while executing your code to prevent resource overlap. What is resource overlap? Resource overlap takes place when more than one driver or process tries to access a device, a single device. Currently, WinDriver occupies my device, so I need to close it before opening the device with my own driver. Okay. Now I want to open the debugger, the WD debug, to show you how useful it is. It is in the util folder. It saved everything that we just did. But basically, you can see here what it is doing. You can see that which functions it used in order to scan my devices, okay, and then to map the memory. Everything we did later was logged here. Every successful operation is colored in green. Functions are clickable and will lead you to our documentation. And failures, which we don't have, as I see, are colored in red. Let's clear the log and get back to it after building our solution. Okay. I'm working with Visual Studio. Let's open, just need a path. Let's open my CMake file list and see how easy it is to build the solution with the CMake. I'll give it 2 seconds to gather all the information it needs and to configure or build the CMake file. Okay, everything is happening automatically. We see that we have no failures. CMake, as I said, includes the information to build the project on different environments. Also, Mac OS. So you can choose, again, different flags. And all I need to do now is to go here and choose CMake target views. I have the Delta project, and I can access my code, the generated code. Okay, so this is the first and most crucial code since it is the logic of my application. Here you can see that everything is automatically generated, all the structs, all the functions, everything. I will explain later how it works because it's not only about these functions. But as you can see, let's go to device open. You can see here the mechanism of how the application is opening devices and how it closes them. And you can see you can see the signature. You have an explanation on which parameter what it does. Sorry. Okay. And on each WDC or WDU function, you can see the documentation inside the IDE. Okay. We jump to the end. Again, interrupts. What functions are we using in order to implement the interrupt handler? You can see again everything here. And now this is the diagnostic functions, the ones that we use in order to create also the interface. So this is another critical part of the code. You can again download WinDriver, generate the code, and explore these files. Explore these files and see how we implemented the code. Now we want to build it, right? So let's click on build all. And we have it ready, right? Build all succeed. Now I will click on F5 and run the application. Here I have it. We have a note here that says it is strongly recommended to run the debugger while using this app. I'm sorry for the cutoffs. My throat is sore, so I'm coughing and I don't want it to be in your ear. I'm not disappearing. It's only a minor cough. Let's open the debug monitor, and here we can see, right? Once we opened our driver, this WDC driver open, all the functions it used. We can see it mapped, the kernel, the addresses, and so on. We have a failure. What this failure means, it says KP open driver failed. That's because we don't have a kernel plugin installed on our project or implemented on our project, so we can ignore it. But again, see how useful it is. If you have a failure during the run of your device or for your driver, you can monitor everything here. If you go to settings, you can send it to the operating system kernel debugger. In Windows, it's WinDBG. On Linux, it's dmessage. Choose the level, choose the status. And if you change the kernel module name, make sure to update it here. We'll talk about it later. Very, very useful. Okay. Let's open our application and see what it gives us. So we see that the driver is bound to a specific device, the one we chose. We can see the interrupt types, the memory range, 1 bar we said. We can scan the PCI bus on the computer or find a specific one. Let's start going through everything here. So remember when we saw the configuration space earlier, when we opened the wizard, you can do the same here. You can read and you can see the PCI registers defined in the configuration space. You can read from them, write to them, scan the PCI capabilities. Okay. We can see here the capabilities that are built in the device itself. Read from offset, write to offset, etc. Again, no code so far. Not a single string. Let's say I want to allocate or free memory for DMA, or allocate or free memory for shared buffer. What is a shared buffer or a memory for DMA? It's essentially capturing a segment of memory in the RAM, okay, memory, to utilize for the DMA or for any other purpose. So I'm choosing 3, allocate free shared buffer. I can choose either contiguous or non-contiguous, scattered shared buffer. I want the contiguous. I want it to be 12,000 bytes wide. And here I have it. I'm getting the user address, the kernel address, the size. And this way I can access this buffer. I can fill it in with info, read from it, clean it, do whatever I want with this memory segment, done with really a few button clicked. Very, very useful if you want other processes or specific segments to store specific data. No hassle. Let's free it. We can do the same with DMA. Okay. So now let's see. Remember when we talked about the predefined action flows? So you create a flow of actions, and you can make them run one after another with this PDA. So they appear here. We call the RPDA calc. So if I choose calc, it will perform the PDA. Again, Delta main menu, manage IPC. What is IPC? IPC stands for inter-process communication. As we said, it is not recommended for more than one process or driver to access a single device. Why? Because it can cause a resource overlap. You can create a mechanism to separate and like access mechanism, but this is not something we recommend, and we don't have such feature built in. What you can do is to bound one process to your device, and this process can broadcast the messages to other processes, inter-process communication in a group. We have a dedicated webinar for this as well, or look on our documentation. This is a special API that costs more. It doesn't come with the basic license features, but it is open in the evaluation license, all of the APIs. You can enable and disable the device's interrupt if it has, and we saw that our device has an MSI interrupt. And yeah, so here we have it. We have our application that was done with no code, really fast. Again, I explained every part of it, but it can be done in, I don't know, five minutes to have a running and working driver that accesses your device and even performs specific operations. Let's go back. This folder contains the build. Okay, this is my application. Here it is. Data installation include system files, and it also the Redis folder for distributing your driver. It's not on it. The drivers we develop are not meant to work solely on the development machine, but to be distributed. And here we have everything we need in order to distribute our driver. A catalog file, system file, two INFs, one device, one driver, we'll talk about it. Install batch file for the driver and uninstall file. The test certificate I talked about, the WD reg, and the GUI. So we have everything we need here in order to distribute the driver as well, and not only for developing it. Okay, let's go back to the presentation. So we said this is the flow: generate code, modify it, compile, run, and distribute. Easy user mode driver development, cross-platform, works on Linux, Windows, and Mac OS. You can generate code in different languages, supports any USB or PCIe device, and enhanced support for specific chipsets from Altera, Xilinx, and Lattice. What benefits WinDriver offers? Comprehensive documentation, support, highly available support, technical sessions, webinars, blog posts, everything you need in order to succeed in using WinDriver. Up to date with the latest kernel versions. So you probably know that when you upgrade your kernel versions and then things starts to break. With WinDriver, you don't have this problem because our development team makes sure that WinDriver is kept aligned with the latest kernel version requirements, either Windows or Linux. So if you upload the kernel version and something breaks, just upgrade WinDriver as well, and you're covered. We talked about the INF mechanism and the fact that it is automated. Simple distribution packages, we just seen. This is a feedback we got from clients that says, because WinDriver is so functional and elaborate, it is easy to hand off the driver between teams in the development process. Okay, from the hardware engineer to the firmware engineer to the software engineer, all of them, they all have a common language, not the one that was invented by one developer, but WinDriver's common language, and we saw the functions and how they are built. So this is another great benefit WinDriver offers. How does it work? So we want our driver or our application to communicate with the hardware. How it is done? What we've generated on the wizard, it is a device INF, which allows the access to the device itself. What asks the access or communicates directly with the hardware is WinDriver kernel module. Okay, we can see it here. Let's open the device manager. This is WinDriver's kernel module, device INF. Sorry, I'm sorry. The device INF is the one we've generated with the name of our device. The driver INF is communicating with the kernel module. And this is, okay, WinDriver's driver INF that communicates with WinDriver kernel module that communicates with the hardware. Now, one critical thing to understand is that the API where you define, or the high-level API we recommend to use, are high-level APIs that are configured and, let's say, run from the user mode, which makes the development easier and the debugging easier because it won't cause a crash every time something went south. So WinDriver API, a high-level API, communicates with the low-level API of WinDriver, and this access is possible using the driver INF. And remember, when on the Redis folder, we have also a device INF and driver INF of your driver in order to distribute it. You don't want to distribute your driver with WinDriver's INFs. It may be complicated for someone who is not familiar with the concept. We have videos, we have a webinar, and we have the documentation. And if you have more questions, contact me. But this is how it works. High-level API from the user mode communicates with the low-level API from the kernel mode, and accessing your device essentially from the user mode. Okay, so we talked about the kernel module. It sits in the kernel mode. The programs, applications are linked or communicates with the driver INF, and each device has its own INF. Okay, again, we don't recommend to connect more than one program to each device in order not to create a resource overlap. Let's talk about the top functionalities. Reading and writing to the device. We saw that very easy from the wizard, from the code, and from the user application. Same interrupt handler. You can listen to interrupt, add transfer commands from the wizard, from the code, WDC int enable, and from the user app that you build. We host a webinar, again, about interrupt handlers in March. We have a recording of a previous webinar on this subject in YouTube and our website. Sign up, it's free. Contact us if you don't have the details. Highly recommended. A really interesting webinar for how to implement interrupt handler in your driver. Okay, DMA. That's a big one. The next webinar is DMA. What is DMA? I haven't mentioned. DMA is performing operations without involving the CPU, okay, directly from the device to the memory. Enhances the performance significantly. We offer DMA sample where you can, first of all, try it yourself and also see how we implement the DMA. This is how it looks like from a user app. Okay, select the DMA method, polling interrupt, select the DMA direction, choose the channel, number of packets, and offset, and it happens. I want to show it to you. If you'll go to the samples folder, see, Xilinx, XDMA, okay, you will be able to see this project. Just for the fun of it, let's open it here. I believe I can open it. Okay. It will take less time because it was already configured. Okay. So this is the code for implementing DMA, WinDriver's code. Here we have it. This is a basic one, but WDC DMA scatter gather buff lock. In order to lock a scatter gathered buffer, this is the function. This is the signature. This is what it does. You have everything really ready and free on our sample folder. So if you are interested and you have familiarity with this concept already, don't hesitate. Download WinDriver and explore this sample and see how it can be implemented easily. Go back to the slideshow. CMake file. I've talked about it. We saw how easy it is to build solutions. Kernel plugin. As I said, the chunks of codes are moved to the kernel mode. You can create an interrupt handler here. Immediate interrupt handler, interrupt trace, enhances performance, less context switch. No additional kernel debugging is required as everything is being set up from the user mode. Predefined actions, okay, talked about it, saw it, set the flow, test it, generate the code, and then run and distribute. No other hassle to perform it. Define the registers, create a predefined action flow, set it based on the offsets and the access registers, and then you can see it on the code and the application as we saw. We talked about the dynamic library. We have the UI, we have the logic, and you can take just the logic and create a separated library, including only the logic. Let's talk about utilities. We talked about the debugger, WDReg, and we have the samples. Why are samples utilities? So first of all, these are working codes. We've tested them. You can use them in order to learn how to implement your own functionality and even run them and see if you get errors. The samples are here, WinDriver samples, and I recommend on the PCI diag or USB diag and the Xilinx DMA. The PCI diag is a working code. You can run it, and if you don't have any issues running it, you shouldn't have issues running your code. If you have issues running your code and the PCI diag is working for you, then something is wrong with the modified code. However, if PCI diag is not working well, there is something that probably went wrong between the operating system and the hardware, again, because it is a working code, which makes it a great debugging tool. We have special APIs for kernel buffer, IPC, I've talked about it, virtualization of devices, server API for more than 100 devices. We offer digital signature services as Microsoft partners, so you can distribute your driver with the ease of mind. We offer one-on-one sessions, technical sessions, webinar, any technical assistance that you need, you can reach us out, and follow us on LinkedIn. Jungo WinDriver, to stay updated with the latest updates. Thank you very much. You can write questions on chat. You can send me an email with requests or questions. You can contact our sales. And I want to thank everyone who attended here.